In this lesson, we're going to learn about integers. We'll learn how to identify them. We will learn how particular terms or phrases can represent a positive or negative number. We're going to compare and order integers and apply the absolute value concept. So before we begin, you're going to use your handout to take notes to fill in the blanks. At any point you need to pause the video, please do so. So once we finish one section, then you can practice the problems on the handout and then continue back with this video. So let's get started. So there are numerous number systems, and you begin learning these in elementary, and they can be broken down into subsets. So generally the first subset that we learn as individuals is called the counting numbers. And sometimes people refer to these as the natural numbers. And the reason that we may call them natural numbers is because that's what we typically learn when we're like two or 3 years old and we're actually learning to count items. So that's why they're called counting, but we just naturally start counting our fingers and blocks and things like that. So counting numbers represent items that can actually be counted. So we're going to put this in the very most center of our diagram here. So the counting numbers, and I'm just going to use this symbol to represent the word number. So the counting numbers are 1, 2, 3, and so forth. Then we extend the number system with another subset called the whole numbers. So the whole numbers include the counting numbers plus the number 0. So we have the whole numbers. So we have 0, 1, 2, 3. So see how this counting numbers portion is a subset of the whole numbers. So that means whole numbers are 0 plus the 1, 2, 3. So we can just write the 0 and understand that 1, 2, 3 is also in this box, or we could write some out. So if you would like 0, 1, 2, and so forth, however you like to write in your notes. So just know that all whole numbers are also counting numbers. And the difference between the counting numbers and the whole number subset is we include 0 as a whole number. The next subset is integers. So this is what this lesson is all about in this unit. The next subset is integers. So integers include the whole numbers and their additive inverses, or another way to say it is the opposites. So let's write integers in this outside box. So integers include whole numbers, 0, 1, 2, 3, 4, which also include the counting numbers, 1, 2, 3, 4. So an integer is a whole number and also a counting number. So we can look at this as we have -3, -2, -1, and here comes the whole number 0 plus our counting numbers, and so on. So you can see that integers are positive and negative numbers. So on the number line, the whole numbers to the right of 0. So we're looking at the right side of 0. So let's just take a look at the number line right quick. So 0 is also called the origin. It's where we begin on our number line. So we're going to compare a lot of things to the number 0 in this lesson. So the values to the right are positive numbers, and the values to the left of 0 are negative numbers. So taking good thorough notes is going to be very useful, especially whenever we get to the quick check quiz. Okay, so we could see that -3 and 3, these are opposites. Those are additive inverses or opposites. So we can see that +3 is 3 units to the right of 0, where -3 is 3 units to the left of 0. Each number has an opposite. Opposite numbers lie equally distanced from the origin. You can also just think of it as the number 0. The opposite of a number is called the additive inverse, which we just talked about. A pair of opposites results in the value of 0. So when you combine an opposite pair of numbers, you're going to get the value 0. Let's also go ahead and fill this back in. These are our negative numbers. These are our positive numbers. So notice, so make sure you notice, there are no fractions or decimals in any of these subsets. So integers are not fractions or decimals. So integers are the whole numbers, 0, 1, 2, 3, 4, and their opposites, the negative. Okay, so if you want to pause the video and complete this part of the handout, and then continue when you finish. Okay. Okay, now let's continue with our lesson on integers. In real life, there are many situations where we use integers, and a few of those include like the thermometer. You can see here that we have 0, our origin, where we begin with, and above, as the temperature rises, our numbers get larger, and these are positive numbers. But below 0, when the temperature drops, then we can see the numbers getting smaller and we have negative numbers. So as we go down on this number line, this thermometer, our numbers are getting smaller and smaller. Another situation where we have positive and negative numbers is above and below sea level. So here is the sea level, which represents the origin, 0, and we can see this mountain is 1,025 meters above the sea level, so that is a positive situation. But down here underneath the sea level, we are at 155, and it's represented with a negative value. Another situation I like to think of with integers is money. Whenever we withdraw money from our bank account, like using the ATM, when we take money out of the bank, then that is a negative situation. But when we put money in the bank account, into our bank, that is a positive situation. Okay, so let's take a look at some of the phrases. So gain versus loss, for example, in sports like football, if you gain yardage, that is a positive situation. But if you lose yards, that's a negative situation. And what about a business? If you profit, that is a positive value. But if you take a loss, that is a negative situation. Above and below sea level, as we just spoke about, above sea level is a positive integer, and below is a negative value. Or again, like the thermometer, above and below 0. Above, as the temperature rise, we think of positive, and when we say below 0, we think of a negative value. If you earn money, that is a positive situation, but if you borrow and you're in debt, we think of a negative value. Okay, how about ascending, meaning going up? That would indicate positive. Descending, going down, is negative. And if you deposit money into the bank, then that is a positive value. But if you withdraw and take money out, that is negative. So if you want to pause the video right quick and finish 7 through 14 on your handout, and then come back when you are done. Okay, let's move along and take a look at this number line. Here we have a horizontal number line. Again, we have our origin 0, and you can see that numbers to the left, these numbers are getting smaller and smaller. And as you go right on the number line, the numbers get larger and larger. So let's compare integers. So we have 3, and we're comparing it to 0. So we can see that 3 is greater than 0 because 3, which we know this, but you can see it lies to the right of 0. Numbers to the left are smaller than the numbers to the right. So let's remember that we're going to say 3 is greater than, so our symbol, as some people say, the symbol is open to the 3. So this is 3 is greater than 0. Now let's look at our next example. We're going to look at -2 and 0. So we can see -2 lies to the left of 0, so it's less than. So -2 is less than 0. Example 3, we're going to look at -1. So -1 and -4. -4 is to the left of -1, therefore -4 is less than -1, and or we could say -1 is greater than -4. So -1 is greater than -4. The numbers to the right are greater than the numbers to the left. In our last example, we have -5, and we're comparing it to -1. -5 is less than -1, or if we go the other way, -1 is greater than -5. So in our statement, -5 is less than -1. So you could see if this was like temperature, -5 is colder than -1. So sometimes you can just remember those situations as the temperature or, gaining money, losing money. So if you want to pause the video and use your less than and greater than symbols to finish the handout, and then you will also order these from least to greatest. So you can pause the video and then come back to finish up the lesson. Okay, let's talk about absolute value. This is super important when we are talking about integers and in the lessons that we're going to have after lesson 1-1. So the absolute value is the distance a number is from 0 on the number line. And since we measure things like distance with positive numbers, the absolute value of any number is always positive because it is a distance. And the symbol that is used to represent the absolute value are these vertical bars. So there'll be some number sandwiched between these two vertical bars. The expression -5 and 5, when we have the absolute value symbols around them, both represent the value 5 because -5 and +5 are 5 units away from 0 on the number line. So let's take a look at this. So if I have the absolute value of -5 and I have the absolute value of +5, what that is saying is we're starting here where these stars are. This is -5, but when we put the absolute value around, it is just asking how far is that integer back to the origin of 0. It is 5 units. Just as if I say, what is the absolute value of 5? We are asking how far is 5 to the origin or to 0. +5 is 1, 2, 3, 4, 5 units to 0, just as -5 is 1, 2, 3, 4, 5 units back to 0. So absolute value is a distance. So if I said, what is the absolute value of -3? It's saying if you're starting at -3, how many jumps does it take to get back to 0? 1, 2, 3. Now, let's take a look at this. Negative, the negative of absolute -5 and the negative of the absolute value of +5 represent -5. So you're like, wait a minute, what's going on? And it's because there is a negative sign on the outside of the absolute value symbols. A negative on the outside means the opposite of. That's what negatives mean, the opposite of. So, order of operations. Just as with parentheses, the absolute value symbols serve as grouping symbols. So let's take a look to prove why our answers to these are -5. So when you are looking at an absolute value expression, you need to evaluate inside the absolute value bars first. So we just learned that the absolute value of -5 is 5, but now we have this understood -1 on the outside, and so we're just going to drop it down, and it belongs with this +5. So what this is saying is, what is the opposite of the absolute value of -5? We said the absolute value of 5, I'm so sorry, the absolute value of -5 is 5, and this is just saying, what is the opposite of 5? Well, it's negative. Now, again, we're going to first evaluate inside the absolute value symbol. So the absolute value of +5 is 1, 2, 3, 4, 5. Then we have this negative on the outside, which means the opposite of. So what is the opposite of 5? Well, it's -5. So just remember, when we have negative on the outside of the absolute value sign, our answer will be negative because it means the opposite of. Okay, let's look at 4 examples. So this is just saying, what is the distance that -21 is to 0? It's 21 units back to 0. What is the absolute value of +21? So how many jumps does it take to get from 21 to 0? It takes 21 jumps. Our example 3, we're going to first evaluate inside the absolute value symbols, which we just did here when we got 21. But this negative on the outside means, what is the opposite of +21? -21. Here we have negative and then times the absolute value of 21. So we're going to evaluate inside the bars first, which we did up here in example 2. So we're ignoring this negative right now. The absolute value of 21 is 21. But this tells us to ask, what is the opposite of +21? It is negative. So if you want to pause the video and complete these, you're just given the absolute value, you're taking the absolute value of 25 through 32. On 33 through 38, you need to first evaluate and then compare using greater than, less than, or equals. So pause the video and come back to our last section. Okay, now let's take a look and use absolute value when we're measuring distance between two values where one is negative and one is positive, and we want to know the distance. So here we have Mount McKinley is 20,320 feet above sea level. So that is a positive value. And if I don't think we mentioned this, but anytime we have a positive number, you do not have to write the plus in front of it. It's understood. So we have 20,320, and we're trying to find the distance between the two. So from here from Mount McKinley to 0 to sea level is 20,320, and then plus we have below Death Valley is 2,882 feet below, so we're going to represent that with a negative value because it's below sea level, but we want the distance from Death Valley from here to here plus the distance from sea level to Mount McKinley. So we are going to add the absolute values of these to get the total value. So 20,320 is from here to here, plus Death Valley is from here to here. So it's that distance. So even though where Death Valley lies is a negative number, we're going to take the absolute value because we need that distance. We're adding these two values together to get the total distance. So we're going to take the absolute value of both of these numbers, and then we're going to add them together. So we get a total of 20,602. This is feet. So that is how far from the top of Mount McKinley to the bottom of Death Valley. That is the distance. Okay, so you finish these up. This is the end of this lesson. Once you finish all of the handout, you can check the answer key and make corrections and then move on to the quick check.